Imagine you're tasked with deploying a system that never stops learning, constantly evolves based on new data, and has the potential to either revolutionize your business or cause chaos if mishandled. This is the reality of AI implementation in enterprise environments. I'm Rob Llewellyn, and today we'll explore how successful organizations achieve excellence in AI implementation and deployment by navigating technical, operational, and organizational challenges. Now, whether you're just starting your AI journey or scaling up existing initiatives, understanding what separates successful deployments from failures is really key. So let's break this down into three essential pillars for AI implementation success. You've got building a strong data foundation, crafting a scalable architecture, and achieving operational excellence. So first, let's talk about the data foundation. Now, AI thrives on high-quality, relevant data, and without it, even the best algorithms are going to fail to deliver meaningful results. I've seen organizations really rush into AI projects only to discover that their data just isn't ready. And they end up spending more time cleaning and organizing data than working on AI itself. In industries like finance, where AI models are used for fraud detection, poor data quality can lead to false positives or missed risks, directly impacting revenue and regulatory compliance. In retail, AI-driven recommendation engines rely on clean, up-to-date customer data to provide personalized shopping experiences. But without well-structured data pipelines, these systems can produce irrelevant or inaccurate recommendations, and that can erode customer trust. So the key is to invest in robust data pipelines that ensure your models have access to clean, up-to-date, and well-structured data. And this includes automating data collection, validation, and transformation processes. Remember, the quality of your AI outputs will always depend on the quality of your inputs. If you build your AI on poor data, you'll only accelerate bad decisions. Now, once you've got your data in order, the next critical pillar is crafting a scalable architecture. But unlike traditional software, AI systems require specialized infrastructure that can handle model training, versioning, and continuous monitoring. In healthcare, for example, AI models used for diagnostics need scalable architectures that can support frequent retraining as new clinical data becomes available. Now, this ensures models remain accurate and up to date with the latest medical research. A well-designed AI architecture isn't just about deploying models. It's about ensuring they can be updated, retrained, and integrated seamlessly into your existing systems. Leading organizations use MLOps, a set of practices combining machine learning, DevOps, and data engineering to streamline AI deployment and lifecycle management. And by adopting MLOps, they ensure that their AI systems remain reliable and adaptable as business needs evolve. A scalable architecture also means thinking about where AI runs. Is it in the cloud? Is it on-premises or at the edge? In logistics, for example, companies are increasingly adopting edge AI to process data from IoT sensors in real time. And this reduces latency and enables much faster decision-making in warehouse operations and delivery routing. Each option comes with trade-offs, of course, in cost, performance, and security. And choosing the right approach for your organization really depends on your specific use case and constraints. Finally, achieving operational excellence is what turns AI from a promising pilot into a long-term value driver. The deployment phase isn't the end, though. It's just the beginning, actually. Unlike traditional software, AI systems require continuous monitoring and performance management because the world around them is constantly changing. Models that performed well yesterday might underperform tomorrow if the data distribution shifts. In manufacturing, for instance, predictive maintenance models need regular updates as equipment usage patterns change over time. And without continuous monitoring, these models can produce inaccurate predictions, and that can lead to unexpected downtime. So the solution is setting up a robust monitoring framework that tracks key metrics such as accuracy, latency, and drift. So by continuously monitoring and retraining models as needed, you can ensure consistent performance and avoid costly errors. But operational excellence isn't just about technology. Of course, it's about people. AI can introduce new risks and concerns, from trust in automated decisions to potential bias in outcomes. In insurance, for example, AI models used for claims processing need to be transparent and explainable to ensure fairness and maintain regulatory compliance. Now, building trust in AI requires transparency, explainability, and clear communication with stakeholders. Involving key business leaders really early and providing them with insights into how AI decisions get made can go a long way in building trust. Of course, even with these pillars in place, there are still going to be some common pitfalls to watch out for. And one of the biggest challenges I've seen is organizations trying to scale AI without fully validating its impact during the pilot phase. A successful proof of concept doesn't guarantee success at scale. That's why it's really critical to rigorously test AI pilots before moving to production. Now, another common pitfall is underestimating organizational resistance, because AI often changes how people work, and that can create fear and pushback. The best organizations address this by involving their employees in the transformation process, offering training and focusing on how AI can complement human roles rather than replace them. So, how do you measure whether your AI implementation is truly successful? Well, you can start by defining clear business outcomes right from the outset. And these could be cost savings, revenue growth, improved customer experience, or faster decision making. Then track technical performance metrics like model accuracy and system reliability alongside these business outcomes. In telecommunications, for example, companies often track improvements in network optimization and reduction in customer churn, and that allows them to assess the success of AI-driven initiatives. Now, ultimately, AI success isn't just about technical brilliance. It's about delivering measurable value to the organization. Now, before we wrap up, let's briefly touch on future trends in AI implementation. Edge AI is becoming increasingly important as organizations look to run AI closer to where data is generated. In automotive, connected vehicle platforms are generating vast amounts of real-time data, and Edge AI is enabling faster, safer decisions without relying on cloud latency. AutoML and advanced ML ops tools are making it much easier to deploy AI at scale without requiring large teams of data scientists. And finally, responsible AI is gaining traction, with more organizations understanding that they need to focus on fairness, accountability, and transparency in their AI systems. Organizations that prioritize responsible AI, they won't just mitigate risks, they'll also build stronger trust with customers, regulators, and employees. Now, if your organization is ready to take AI implementation to the next level, focus on these fundamentals: a strong data foundation, scalable architecture, and operational excellence. These are the building blocks of long-term success. So listen, if you're ready to improve your skills and lead AI deployments with real confidence, check out the links below for more resources and tools. Thanks for watching, and I'll see you in another video.